Okay, yesterday we have seen about big decimal. So that's about primitive data types we have seen yesterday. So today we'll start a fresh topic. So today I'm going to discuss about the conditionals, which I already discussed, particularly the if-else statements. So if-else statements I already stated in the first chapter for our multiplication table, but I have not discussed it particularly like nested if-else and switch statements, and how to take input from the user. All those things we have not discussed. So let me brief them very quickly so that I will cover even those basics within no time. So let me cover those if-else statements. Okay, so let's see that. So before I go for if-else statements, I want to discuss even about relational operators, relational and logical operators. So let me do that quickly. So the first topic is relational and logical operators. So let me use JShell for this so that I will get the immediate results. So let me open command prompt and type JShell. Okay, this enables JShell. Now what I need to do is, so for example, I am taking a boolean variable, and okay, that's okay. I am taking an integer variable. Int I is equal to some 8. Now I want to check whether I is greater than 2. Obviously I is greater than 2, and you will get an answer as true. If you type I is less than 5, then it is false. So this type of checking, this type of operators in between are called relational operators. It is establishing a relation between left hand side and the right hand side. So less than, greater than, and if you want to compare whether it is exactly equal to, then you need to use double equal to, then it returns true. So if you use single equal to, it is an assignment operator but not a comparison operator. So this less than, greater than, less than or equal to, greater than, or even you can use this one. So I less than or equal to 8. So even this is true because one of the condition is getting matched. So since one of the condition is getting matched, it is not less than but it's equal to. So hence it is printing output as true. Okay, now even you can have greater than or equal to. All these are called relational operators. Then what are logical operators? Let's see. Sorry. So let's see what are the logical operators. So the logical operators are nothing but, for example, you want to check whether 8 is in between 10 and 20. Is it in between 10 and 20? You want to check. How you'll check? I greater than or equal to 10, and you have one more condition. So you cannot write and. So in programming you need to use these symbols for making the both conditions possible. So and I is less than or equal to 20. You want to check whether the number is between 10 and 20. So both conditions need to be satisfied. Then is it between 10 and 20? No. Obviously you will get the answer as false. So let's see those logical operators. So the relational operators are less than, greater than, equal to, and the combination of them like less than or equal to, greater than or equal to. Okay, so these are the relational operators. When it comes to logical operators, you have and, or, you have and, or, and you have. So what is and? And is nothing but it's a logic gate for and. So you have two inputs, x and y. So when the first condition is true and the second condition is true, then only the output will be true. In remaining all cases, the output will be false. So if you write and means both the conditions need to be true, then only you will get the output as true. So that is the logical table for and. When it comes to or, this is and this is or. When it comes to or truth table, so you have two inputs, x and y, and you have the output. If either of them is true, then the output is true. Or you can simply remember, if both are false, then only the output will be the false in case of OR logical operator. Okay, so these are the basic two operators we'll be using. So you can type anything. So if you want, you can check here. So you can check directly here. So it is checking for the first condition. I is greater than 10. Is it checking? I is 8. 8 is greater than 10. No, it's false. And second condition. So 8 is less than 20. 8 is less than 20. Yes, 8 is less than 20. This is true. So one condition is true, one condition is false. Obviously the result is false. Okay, so second condition is correct. 8 is less than 20 is a correct one. So false and true, even if one of them is false, the output is false. Now you can check directly here. You can type true and you can check. All should be small letters. So true or false, which means I am checking OR operator using, I am writing directly the expression, first expression as true and second expression as false. You can even evaluate this. If you evaluate, you'll get the output like this. I hope you understand. I hope you understood. So if you write any expression here, it will give an output. Directly I'm writing the outputs here and I'm checking. So the output is true. Okay, so these are and OR operators. So for example, you want to have NAND and NOR. So you have all the logical operators. So not is a one more logical operator. So we have three primary logical operators: and, or, and not. So this is and, or, and this is not. So these are the three logical operators you need to know. Okay, so primary operators. So not is nothing but it's like a negation. Okay, so not of true is false, not of false this is true. So you need to just type an exclamatory and type true, it will be false, and for false it is true. Okay, so not will just negate the result of your expression. Okay, so for example, I value, what's I value? 8. So I am checking whether I is equal to 2. Obviously answer is false. But if I make it as not, let's see, not, you can put it in a bracket. So what I am doing, this is false, I equal to 2 is false, I am making not, so it will be true. I hope you understood. So this about NAND, and, or, and not. And also you have other secondary operators called secondary operators you can make with this. So just put a exclamatory in front of and, that becomes NAND. Okay, and put an exclamatory in front of or, it becomes NOR. Okay, these are the additional gates. And also apart from this, we have something called XOR. XOR sometimes we'll really use, sometimes we do really use. So XOR operator is generally denoted in Java with a cap. XOR is denoted with cap. So you are in such a requirement that if one is true and other is false, see, true true, true false, false true, and both are false. Okay, so what I have did previously is we have a gate, sorry, just a second, we have a gate which handles if both of them is true. If both of them is true, then the output is true. Okay, we have gate for this. If both are false, then the output is false. Even we have a gate for this. Okay, the same, which means if you take NAND, if true true, it becomes false. Okay, if it is false false, it becomes true. Okay, don't worry about that. So basically you need to see the inputs only. Okay, so if both are true, we have a gate. Output can be true or false based upon NAND or AND. So if both are false, we have false or true. We have OR operator, but we don't have a gate for the second and third inputs. The second and third inputs gate is XOR. Which means if both one is true and other is false, then only it will say I'll be true or else I'll be false. Okay, and this you can change it to false by using other gate called XNOR. XNOR is nothing but not of this will become XNOR. Okay, depending upon your requirements, you may use even these two gates. Okay, so one is true, other is false, then only the XOR output will be true. You can check here, true XOR false, then you'll get the output as true. Okay, so these are the gates you need to remember. So the primary gates are like and, or, not, and even XOR, and the secondary gates have the negation ones like NAND, NOR, and XNOR. Okay, fine. So this about gates. So depending upon the requirements, you need to use this logical operator. All these are called, all these gate operators are called logical operators. Just if you have less than, greater than, all these are called relational operators. Okay, I hope you understood. So for a logical operator, in order to use this logical operator, definitely you need to have at least two expressions, two relational expressions, two expressions you need to have. In between you can use the logical operator. So here you can have a relation once, x greater than 5, I less than 5, whatever, just like we did here. So you'll have two relation, or even it will not be relation, you can directly use true and false, two relational operators. In between you will be using a logical operator. That's a small topic we have covered the start of the section. Now let's see one more small topic. Let's see one small topic called short circuiting. The same concept is again there in Python. Let's see what is this short circuiting. Short circuiting is nothing but, for example, I'll give an example. Let's see, tell me the output. Okay, so try to predict the output. I'll wait for your response. Okay, so I'm giving a question. So the question is, okay, I is equal to, I'm making I as 10. Okay, I is 10, and j I'm making it as 15. I is 10 and j is 15. Okay, now what I'm doing is j greater than 15, j greater than 15, and I greater than 5, I greater than 5. What's the output? J is greater than 15. First is false. Okay, second one, I is greater than 5, it's true. False and true and is false. Obviously the result will be false. Now this is not my question. My question is I plus plus greater than 5. Now let's see what's the output. What's the output? J greater than 15, right? J greater than 15. So j greater than 15 is false. Then the second expression, I plus plus will be I 10. So it's a post increment. Post increment, it will not assign the value directly. It will be I value will be 10. 10 greater than 5. It's true. False and true output should be false, right? Now my question is, what's the value of I and j after this execution? This is false, obviously. Okay, I want the response even. Let me pause this. See, interestingly, the j value is 15. That's good. But I value initially here it is 10, but it's a post increment. Now by the time I execute, it should be 11, right? But surprisingly it will be 10. Surprisingly it will be 10. What happened? Why this has been not post incremented? Which means it has been not post incremented, right? So that is surprising. There comes the concept of short circuiting. There comes the concept of short circuiting. Why this I plus plus has not been incremented? Why means, see, what's the truth table for AND gate? If any one of them is false, the output will be false. If any one of them is false, the output will be false. So how all compilers are designed? They are very smart enough. So first one, j greater than 15, is it true or false? It is false. J greater than 15 is false. So the compiler, it will not even check the second expression of the complete expression. This complete expression, the second part, it will not even check, because the first part is false in and it will see the AND operator. So in AND operator, if any one of them is false, the output is false. Directly it will return false, and the compiler not even evaluates this expression. Hence the I value will not change. I value will not change. It will not increment. That's the reason you are getting the output as 10 as it is. If you want, I'll prove it. So what I'll do is, I will make this first expression as true. Now the compiler will evaluate the second expression. See, j is 15. So if it is true and then it should check the second one, right? Because you don't know, you cannot conclude whether it is true or false by just checking the first expression. If it is true, If it is true, the second expression can be true or false, we don't know. So the compiler will check for the evaluate the second expression, and if it is true, then the output will be true. If it is false, the output will be false. So first expression, if the first expression is false, the compiler will not check the second expression, because in AND operator, if any one of the expression is false, the output is false. In AND operator, if any one of them is true, then the output you cannot conclude, because it can be, if the other expression is false, the output is false. If the other expression is true, then the output can be C, because you got both as true and true. If the other expression is true, then the output will be true. If it is false, it will be false. So the compiler don't know. So definitely it will evaluate the second expression. So j equal to 15 is true. I is how much? 10. 10 greater than 5? Yes, it's true. So true and true, output will be true. So the output is true. Now what's the value of j? J will not change 15, but I will become 11. I hope you understood. Second expression is now evaluating, because the first expression is true. The compiler definitely has to evaluate the second expression in order to know whether it is true or false. So it is evaluating, hence I is incrementing after this expression evaluation. I hope you understood. Okay, so this concept is called short circuiting. In a short way, you are evaluating. In a short way, you are evaluating. So what happens is, how the logical operators will work. Here you will have a logical operator. Here you will have a relational operator. So logical, relational operator you will have. So if it is AND gate, if the first one is false, and if it is AND gate, then this will not be evaluated. This will not be evaluated by the compiler, because the output is directly false. And if it is OR gate, if the first one is true, and if you have an OR gate, the compiler will not, even it will not evaluate the second one. Why? Because one of them, in OR gate, if any one of them is true, the output is true directly. So it is saving the time of the compiler. See how smart enough the compilers are. So this concept is called short circuiting. It is shorting the directly, it is shorting these two things and giving the output. It is not even evaluating the second expression. Is there anything for XOR? Can we do like that? Let's check. So in XOR, if the first one is true, and in the XOR, if the first one is true, is there anything you can skip? No, you cannot skip. Definitely the compiler has to evaluate the second expression, because based on the nature of true or false of the second expression, then only you can conclude the output. Even if the first expression is false, definitely you need to know the nature of second expression, then only you can come to a conclusion of the output. So XOR, you cannot have a concept of short circuiting. The short circuiting concept is available only for AND and OR gates, and even you will have for NAND and NOR gates. Okay, NAND and NOR gates. Okay, I hope you understood. Let's see the conditional statements if else little bit in detail. So, and we'll quickly wind it up in 15-20 minutes. Okay, so we already discussed if else, so let me go through once again nested if else, all those. So let me do with an example. So you already know basic if else statements. I need not do an explanation. So what I'll do is I'll assign I is equal, what is I value? I is 11 now. Okay, so you can check a condition. If I is equal to 11, then it is waiting for my output. It is not. So system dot I'm printing. Okay, what happened? Oh, sorry, I need to give it in double quotes. Single quotes is not accepted. Okay, so if you want to give it as a block, even you can give it as a block. So how can you give it as a block? Let's see. can give else if directly here. Else if I want to print something, so just I want to show the syntax here. I'll not do coding again for this small thing. I'm printing some numbers, okay. Still you can have the else if. So illegal start of the expression, so 1 second. Oh sorry, else if I'm not providing the condition, that's why it is shouting at me. You can give else. Okay, so if else, so same way you can have, I hope you saw this, if and else, if directly, else directly. Okay, so let me give here directly, so instead of wasting time. So if you'll check the condition, you'll check some condition and you'll write in the braces, and else if you have some other condition, you'll check it. Then still if you have some other condition, you'll check it. So you have some 10 conditions. For all the 10 conditions you'll write if else, if else if else if else if, and finally one default condition. If all conditions are not true enough, then you'll check the final condition. Okay, now we'll see one example maybe. Okay, we'll take a simple example in the Eclipse. This compiler is not good enough now, JShell. So let me take an example. Okay, so let me take a new example maybe. So right click, let me close the JShell. Right click, new Java project. I'm taking a new project. Conditional statements I'm checking through this conditionals. So next what I'm doing is I'm clicking on next and then finish. It creates a conditional project now. Now let me add a source, which means let me add a class, new class, and I need a main method for this because it's a new class now I'm checking. So conditional runner, so this is a runner class. Let me close remaining. So we have a main method. Now what is our requirement? My requirement now is, by this I'll explain even the how to take the inputs from the user. Okay, listen carefully. So what is my requirement is, I'll ask the user to enter two numbers. And I'll ask them to, I'll give an option. I'll give an options like 1 for my addition, 2 for subtraction, 3 for multiplication, like that. I'll give an option. I'll ask him to choose, enter a number. So based upon his response, I'll be printing the output. Okay, let's do that activity so that it covers how to read the input from the user and also how to write the if else statements quickly. Okay, so I have run a class, I have my main method. So what I'll be doing is, first I need to take the two inputs from the user. I need to take two numbers from the user. My requirement is take two numbers from the user and ask the user whether he want to add, subtract, multiply or divide. Okay, so first I need to take two numbers from the user, for which how to take an input from the user is you need to use a scanner class. So just like scanf you have in C, same way you have scanner class in Java. So scanner class, scanner is a class, capital S, and I'm creating an object called scan. So scan equal to new, just like how you create objects, same way you do that, new scanner class. See here what I need to do is, whenever I want to okay, one second. So whenever I want to print something, how I'll be doing that? System.out.println. So system.out, system is a class, output method, and again a sub method, out.println. So these are the three things I'm using. So system.out.println, this is the something. So you can say standard output stream. This stream is already open and ready to accept the output data. So what you need to do, system.out.println. So for the scanner class, see system.out, and you are using a method called println. Out is a parameter. Okay, same way what we are doing is, now instead of system.out, you need to, every time if you want to scan something, you need to send it as system.in. The argument you need to pass it as system.in, then only it will accept. Okay, still you are getting some error. It says that you don't have a scanner class. So import scanner, you can see just over on it, it will give the suggestions directly and it will import the scanner class. That's the advantage of Eclipse. Okay, now I have imported the scanner class, everything is ready, this object is ready. This is orange, which means you have not used the object you have created, but you have not used it. Okay, let's try to use the scanner object and let's print our output. So the scanner object will scan the inputs for us, it will readily print the inputs for us. So what I am doing is, okay, just comment this and try to see the output, then you will understand. So run as Java application, you will not see anything. Will not see anything, that's it. It will not give any output for you. Okay, so what I'll do now is system.out.println, I'll ask the user to enter a number. Enter number 1, or you can say enter first number. You can see this is the output, right? So downside, yeah, this is the output. So but still if you enter something, it is not allowing me to enter, even it is not even allowing me to type anything here. Okay, even though you have scanner class, it is not allowing me to type anything. So you just created an object for scanner class, but you are not reading the number, you are not meant for the reading the number from the user. It is just created a object for the scanner class. So how to read is, it's simple. So how to read is, just type scan dot, if you want to read an integer, just type next. You have all the different things. If you want to read an integer boolean, just type next boolean, next byte. If you want to read byte, double, float, integer, we need integer, we want an integer, so just read integer, next integer. Okay, so this will read a number, now you can go and check the output. So let me run the output. So enter a number. Now I can enter. Now it's allowing me to do. Previously this was not possible with the keyboard. You can try with your keyboard. So now I entered, but this entered value is not storing anywhere. So what I'll do is I'll create a variable and I'll store it in that variable. Enter num1 is equal to this. I hope you understood. So I'm scanning and I'm storing it in a variable called num1. Same thing I'll do with num2. So I'm copying it and I'm pasting. So enter second number, and this I'll take it as num2. That's it. So two numbers gets read, and these two numbers are stored in a variable called num1 and num2. Now I'll ask the user Now I'll ask the user, we have some choices available, one for addition, two for subtraction, all those things I'll ask the user. So system dot, you can simply type sys out control space, it will give directly. So you can say directly here 1 for addition, click 1 for addition, 2 for subtraction, and 3 for multiplication, and 4 for division. Okay, this I am asking the user to do this activity. So I am asking him to enter again 1 or 2 or 3 or 4. If it is 1, we'll add the numbers and give the output. If it is 3, we'll multiply and give like that, 1 2 3 4. Okay, now what I'll be doing is, something is missing here. Okay, this is missing. Okay, now I need to again take the input from the user, either 1 or 2 or 3 or 4. So what I need to do again I need to scan the user response. So it's again an integer, and I'll store it in a variable called choice. Any variable, it's up to you. Okay, now I need to write a code such that if it is 1, I need to add the numbers. If it is 2, I need to multiply, 3 divide, and all those things I need to do. Okay, so let's see all this together very quickly. So for this I'll be using if it is 1. So I'm saying I need to use if choice equal to 1, then for single line statements you need not give a flower braces. Okay, it's up to you. If it is 1, what I need to do, I need to print the output as sys out. I need to print the result as addition, right? So let me print num1 plus num2, right? Okay, so I know it's slow, but we need to understand some minute concepts here. So subtraction, multiplication, it's an division. We get only coefficient, that's okay. Fine. Now let's test if all these are done. We are giving the outputs in this way. Let's test. So enter a number, it's waiting for my response. I'm typing 85. Okay, enter second number, say 5. Okay, it's asking like you want addition or multiply. I didn't type the message. If you want, you can type the message. Okay, so say I am entering it as 3, so it should be 425. So you got the output as multiplication 425, right? Perfect. So you're getting the output. Now what we need to understand here is, this is simple if blocks, all if blocks. So what's a drawback with this? Is, so user has entered 3 as the choice. So but what happens to the compiler? Think of the compiler time. So it will check for if choice is 1, yes it is 1. So choice is 1, no. So it is checking this condition, which means it is wasting some time. So choice is 2, it is checking, so it is not true, so it is checking and wasting time. Choice is 3, yes it is found, it is found and is printing the output. Up to this it's okay, because it need to check these two conditions. Obviously definitely it need to check, because you don't know whether 3 can be here or the choice can match here or here. But even the answer is found here, but there is no necessity to check the below statements. Even the answer is found here, the compiler will check this one, because this is if. Again the control will go here and again it will check. It is already finished, the output is done, but still again it is checking. Still the output is, it is checking the output for 4 also. So it's a waste of time for the compiler for checking the 4th output, because you already got the output, right? So this is the disadvantage with nested if you use continuous ifs. That's a drawback, which means even if you find some answer at middle somewhere, then it will check. Even the answer is found somewhere, still it will check the conditions or the if statements below it. Okay, so if your requirement is something like you need to check every if statement, every if statement if you need to check, that is your requirement, then use the nested if, So in some other situations you'll have a requirement like, if you get the answer, don't evaluate the remaining blocks, if that is your requirement, then use if else, nested if else. So let's see that. So instead of this I'll write else if. So what is happening is, so what I'll do is I'll type 1. So for example, I type 2 now. So let me rerun the program. I type 562 and I type 3. So the answer should be 559 if I type 2. Right. So what is happening now? It is checking my choice is 1 or 2. First I entered it as 2, so it will check for here. Obviously it need to check the above statement, that is inevitable. So 2 it will check here, so it is not correct, so it will go for the next one. Else if it is 3, yes, it is checking and it is giving the output. So it is matching here. Else if choice is 3, it will check or not, let me know. So else, see what is doing is, it is checking this. Else if this matches, done. So this matches. Else if this will also check this, I mean even else if gets evaluated, but the thing is the difference is, okay, I'll tell you. This if gets evaluated, else this gets evaluated, else then this 2 will not get evaluated, that's what I'm telling you. So this gets evaluated, else if it is evaluated, then it's done. Else if this is getting evaluated, done, it's done. So it will not go for else if statements. Okay, it will come to this else means if it is failing, then only in that situation only it will check this. That is the meaning of else, right? The dictionary meaning. So else is a situation where if the first statement is, first option, you have two plans to go somewhere. The first plan got failed, then only you will think of else plan, right? So if the first plan, if this above plan is true or if it is passing, then you will not think of a else condition, right? So that's the difference between if, nested if and nested if else. And you can write, for example, if I enter, so let me rerun the program, and if I enter 55 5 and if I enter some unknown number, say 6, so the compiler don't know what to do because it has only choices for 1 2 3 4. Then you can write a default one stating else. Directly you can type some else, and you can, which means if any one of the above condition is not satisfied, then it will type the default condition. So invalid choice or something you can give to the user. That's a necessity of default else at the end. So if any one of the condition is not matching, then you want to give some prompt to the user. In that situation you can just provide the invalid, the final else for the user. That's the purpose of nested if else, and again at the else at the bottom. Fine. Now this problem, it has some problem here. Again, writing this if else if is okay, it's fine, it's good, but the thing is it is not readable. Readability is very less for nested if else. So before I go for nested if else, okay, before I go for next topic, the readability for this is not good enough. So in order to remove this complex readability, so we have something called switch case statement. Switch case statement is exactly same as if else statement, nested if else. The only difference is the readability. Apart from that, both are exactly the same. So there is no difference between nested if else and the switch case statements. Okay, now let's create a switch case statement for this. Okay, so let me do that. So what I'll do is I'll keep this as it is. So the syntax is switch. You need to type the choice. I'll tell you, I'll explain you. case is a keyword. Case 1, case 2, case 3, I need to give the space, case 4, and default. Default is again a keyword. Let's save. It will be aligned properly. Okay. So by today we'll finish all basics. Don't worry. From tomorrow we'll get new topics. So what I'm doing is I'm comparing in the first statement choice equal to 1. Here you will get the choice. The same choice here is same as choice. So choice, it will check with the first case. Choice value, you need to give the values here. You can give, if you give 10, which means it will compare like choice is 10 or not like case 1, case 2. You need not give in a same order. I hope you understood. So here choice means choice is a variable which user will give the value, and this is the right hand side. This right hand side you are comparing. This right hand side is same as this right hand side. You can give 1 2 3. It's not a numerical order to give in the same 1 2 3 4. You can give any number which you want to compare. So this means that if choice is equal to 1, then this is the output. If choice is 2, then this is the output. If 3, this. 4, this. Else if. All these are else ifs. So same thing. Final else is there, right? This is called default case. So default, if we enter some other number, then just give a default as invalid operation. So this about nested if else and the switch. In the switch, let me execute. There is something which I need to discuss now. So what I need to discuss, I'll tell you. So let me enter first in this way. Okay, I saved and it automatically turned this way. Okay, now let me execute. Let's see what's the output. So enter first number, 58. Enter second number, 3, and I'm choosing an operation as 1. What would be the output? It should be 61, but the output will be invalid. And it computes everything. See, you can see here I entered choice as 1, but it has computed everything. Why it has computed everything? We want to know, right? So we want to know, it has computed first this, again it computed everything. Why it computed everything? So the answer is, so in switch statements what happens is, choice is 1, then it will print this. Okay, it will print this. So if you don't terminate the statements, here, but you need to terminate the statements using a keyword called break. If you terminate the statements, so if any condition gets matched, then it will come out of the loop. Then only it is a if else statements, or else the system will lose its choice value. The user has entered 1, right? It will lose its value. Then again it keep on evaluating the remaining cases also. Without even checking the conditions, they will keep on evaluating. That's a problem with if else. So definitely every statement you need to terminate with a break, which means if that condition is matched, then it will print whatever is you have given in that, and it will break that case, and it will not go for the next statements. Okay, default and then finally break. Now let's evaluate. Now you will get the output. So switch has 3 keywords: switch, case and break. 55, 3, 1. Why it is printing twice? Okay, it is doing this if else also. It is doing this if. I need to remove this because it is doing 2 times. Okay, let me remove that and say it will get the output only once. Now this about switch case statements. Now let's play with switch case statements. I want the outputs from you. Okay, So I hope you understood. If the condition is, if you don't give break, what happens is even the below statements will get executed. Even the below statements will get executed. Now let's try keep on playing with if else. Okay. Okay. So I'll rerun the program. I have removed the statement for the case 1. Okay. Let's see what would be the output. 55, 3, and I'm entering 1. What would be the output? The output is the first case statement, it does not have anything, and it does not have a break also, so it will go for second statement evaluation. It goes for second statement evaluation and it will give the output as 52 and it will break the loop. I hope you understood why we got 52, because the first statement does not have a break. If this first statement has a break, then it will come out and it will not print anything. Since it does not have a break, it will go for the second statement evaluation also. And for the second statement, it will print this and it is breaking, so it will come out of this switch case and it will finally terminate and the control will come here. Okay, so let me do this. Okay, let's play. Okay, let's see this. Okay, let me run the program. So what I'm doing is I'm entering first number 55, second number 3, and my operation is 1 again. If I enter 1, what would be the output? First one, it does not have statement or break, so it will go for second and it will print the 52 as the result. And again there is no break, so it will go for third. Third also does not have statement and break, so first output is 52. And again it does not have break or statement, it will not evaluate. It does not have break first of all, so it will not break. Then it will go for fourth case and it will print num1 by num2, 55 by 3. So it will print the result and it will break. So what would be the output? So the output is, I think, 52 and 18. Yes, that's it. I hope you understood. And the final one, now let's play it this way. 55, 3. Now I'm entering 1. What would be the output? So the case will first go for here, or first it will come from the top approach. That's the question. The question is, what's the output? The output is obviously you'll get this 52 and 18. Will you get this above 1 or not? So my question is, indirectly my question is, when the user enters some choice, it will directly go for that choice or it will check from the starting? Obviously it should print these two things, because default case will evaluate only when the choice is invalid, right? So the choice is not matching. It will not even enter into this. Now consider this situation. You keep on playing with this, then only you will understand. Now you will get an invalid, because the first one, user, if he enters 1, then it will enter into this, then it will check for the remaining, because it does not have a break. Previously this was top of everyone, so it has checked the default case. If the choice is default, like if the choice is 10 or 20 or 30, no, it's not that way, so it is not entering into this. So that's why it's coming to case 1 directly. Now it will print 55, 3, 1. So we'll get this one, this and this. Keep on playing with this. Try to switch here and there with the switch and break, switch case and break. Then you'll get different outputs. Everything has a meaning. Fine. Let's take some 5 minutes break. And so as an activity, you can do this. It's a simple one. So activity is like, take the month number from the user. It can be 1, 2, 3, 4, 5. Then write the switch statement. You need to write the switch statement. and print the output as some May. If it is 5, it's print May. You write all the case if it is 1 January, 2 February, all those you can try it as an exercise. Okay, fine. Now let's go for next concept called ternary operator. The same concept is there again in Python. So in every programming language you'll have all these ternary operators and short circuiting. Even in C++, same concepts, only little bit of syntax it changes, that's it. That you can search in the internet and you can find it. So if you know one programming language, that's more than enough. But the thing is, the frameworks are dependent on these programming languages. So Java has different frameworks and Python has different frameworks and C++ has different frameworks. So you need to know the basic applications core part, then you can easily understand. Some from tomorrow onwards what we are going to discuss may be different from each programming language. So until today we are finishing the core part of the Java. Core part is like basic Java. So from tomorrow we are starting advanced Java. So the topics will be new to you. Okay. So ternary operator is nothing but it is meant for creating short representation for what is the purpose? In order to short representation for if else block. For the if else block, if you want to represent it in a short way, then you can take the help of ternary operators instead of writing in a long way like if else, only for a representation purpose. Even the switch case is representation purpose, readability. Okay, so the advantage is it's one line, but the drawback is it's not readable. Readability is low. Okay, any programmer, if they read, it's less readable. Okay, switch case, the same thing. Advantage is not one line, it's many lines, but it is readability. Okay, so let's see this ternary operator, how to write. So the syntax is write the condition and put a question mark. So it will check the condition. If the condition is true, it will return the first expression. If it is false, it will return the expression 2. So it will check the condition. If the condition is true, it will return the first expression. If it is false, it will return the second expression. Okay, let's do some activity. You can do directly in the J shell. I'm doing directly in J shell, the small operation. So I'll take int I is equal to 10. Now I'll check now. Instead of write, so how I'll check? Directly. No need to write if. Just check. I just write the condition. If you want, you can write in the brackets. I equal to 10 question mark. You are checking it. This question mark is nothing but if. If I is 10, then print. You can write anything. You can type anything, or you can just say true or false. Or you can write simply system.out.println some hi or something, or false. Okay, it will return this one. Okay, if you want, you can do system.out.println, that's okay. What happened? Yeah, one thing you need to remember, here you cannot type system.out.println. Why? It will just meant for evaluating the expression but not for printing the outputs. It's not meant for printing the outputs, it's just meant for evaluating expressions. If you want, you can evaluate expression, mathematical expression. That's why it's saying type error, incompatible types. The type is, this is some function you're calling, but it wants just the expressions. Okay, it is printing 50. It needs just the expressions but not the uh, what do you say, like functions calling, all those are not possible with the ternary operator. Okay, even this concept sometimes useful. Fine. Now next one. Always remember everything should be same here, which means if I type string here, will I get the output? Okay. Yes, you can do this way, but the thing is you cannot call the functions here. Okay, that's a problem. Fine. Now let's see. Yeah, that's about the conditional statements, if else, nested if else, and switch case statements, and finally you have ternary operators. Now let's go for next concept, loops. The loops in Java we'll see very quickly, and that will finish our core part of the Java. So let's see loops. So in Java we have for loop, while loop, and do while loop. You might have known all this, but today we are going to see something interesting, when to use which loop. So you may be thinking all are same, but they are different. At the end of this loops concepts, I'll ask you a question, then you will be in a situation to answer which loop you will be using for that requirement. So you may be thinking for loop and while loop are exactly same, but small difference is there. We'll see what's the difference. Okay, so that's it. They are not exactly same. That's the main difference which we are going to highlight today. Okay, let's see for loop. For using for loop, which you already did, the syntax is so just write for, and you need to initialize the variable, and you need to write the incrementation, or you need to write the condition, and you need to write the incrementation or decrementation, and you need to write whatever you want inside. Okay, let's do an activity. Okay, activity is okay. Okay, let's do an activity directly. I'll go for some bigger one. So I want this as the output using for loop. Okay, let's see how we can do this. Directly I'm attacking a question. So how to print this outputs using for loop in Java? Let's see that. Let me not create another class. Let me use this conditional class itself. So let me print here itself. Let me remove all this switch case, and let me remove the scanner also. Okay, let me enter a number. Okay, first number. Let me enter a number from the user. So let me make him to make this limit up to which number he want, 5 or 6 or 10 or whatever. Okay, fine. Enter a number. I'm scanning and I'm storing in num. So first of all, let's do some simple activity. For int I is equal to, it should start from 1, and it should be less than the given number whatever the user is entering, and I plus plus. Every time it should increment by 1. So what I need to print, sys out control sys out, I'm printing I. So what will be the output for this? I'm not doing the question, just I'm seeing the output. What will be the output? So if your user enters 10, then what will be the output? 1 2 3 4 5 6 7 8 9 and 10. Fine, that will be the output. Let's see. Enter a number. I'm entering 5. So the output is 1 2 3 4 5. Okay, this is the output. See, what's the difference with what's the difference between print and println? Println is nothing but printing in a new line. It prints in a new line. If you just write print, even that is correct, but it will print side by side. You can see here, I'm just making it as print now. It will print side by side, one after the other. 6. So 1 2 3 4 5 6. I hope you understood that's the difference between print and println. Ln means new line. I didn't told you until now. Ln means new line. Okay, so I'm printing a number. If I type 6, it will give me 1 2 3 4 5 6, but this is not my requirement. So my requirement is I want a table kind of stuff, right? So if I enter 5, I'm getting 1 2 3 4 5, right? That's good enough. But the thing is, I want it in the last row. Before this, I need 4 1 2 3 1 2. Again there is some looping. The looping is in the row wise and again in the column wise, which means we need one more loop for doing this activity. So before I do that activity, there is no space between each and every number. So let me create a space. How to create that? Concatenate with a space. Okay, enter a number 5. So you got 1 2 3 4 5, but I want 1 2 3 4 1 2 3 1 2 and 1. So how to do it? So you need, again, this is one line. Like that, how many lines you need? Like that, how many lines you need? 1 2 3 4 5, the number of lines the user enters, the same thing. So I need to write one more loop which does all this activity. So let me take another loop for int j is equal to 1 and j should be less than or equal to I, and I'll write j plus plus. So listen, I'll explain this. First time what happens is I'll copy this code maybe and I'll explain you here clearly. So this is a code you have. So what is happening is, initially I is 1. Okay, say the new user has entered a number as 5. Okay, initially I is 1. So I is 1, so then it enters here. Then j is also 1. Okay, both are 1 and 1, good. J is less than this below 1 will execute, the below 1 will get executed. Then it will not check any condition. J is less than I. Yes, 1 is less than or equal to 1. Yes, it's true. So immediately it goes to here and prints the value as I. I is printing, so output is 1. Okay, next time what it will do is j gets incremented because the inner loop need to be incremented first. So j becomes 2. So when j is becoming 2, now again it will check the condition. 2 is less than 1. Is it true? No, false. So immediately this loop will break, and the control will go for the top loop. Now I becomes 2. Now I becomes 2. And I is 2, I less than 5, 2 less than 5, that's correct. Again j is reset to 1. So again j is reset to 1. Now the condition it will check. 1 is less than 2, that is true. Then again it will print I. I is how much? I is 2. But you want to print I or j? You want to print j. So if you print j, what happens is you will get 1 as the answer. Then next time what happens? J becomes 2. 2 is less than or equal to I. 2. Yes, that's true. So again it will print j as 2. Right? Now j becomes now 3. 3 less than 2. That's false. So I becomes 3. So when I is 3, j again resets to 1. So again you are printing j as 1. Then j becomes 2. You are printing j. J becomes 3. 3 is printed. Again j becomes 4. 4 is less than this I. No, 4 is, that's false. It becomes 4, and again the process continues and you will get the output in this way. So try to analyze after class what we are doing. So here I need to print not j I, it's j. Okay, if you print I, you can see the result. It will be wrong. So it's wrong. We don't want 1 2 2 3 3 4 4s and 5 5. Is that our requirement? No, we need 1 1 2 1 2 3 1 2 3 4 and 1 2 3 4 5. So we don't want I, we need j. So let's print the output. Enter a number 5. So yes, we are getting 1 1 2 1 2 3 1 2 3 4 and 1 2 3 4 5. But every time I finish j, I need some space. This is first value of j, 1, first iteration of j. Then the second iteration of, I, second iteration of I. These two are j values. Then third iteration of I. Then fourth iteration of I, fifth iteration of I. So every time I gets j finishes its loop, I need something to be in the new line. What I need, system dot sysout, just sysout, that's it, leave it. So this will take into new line. Already it will, if you don't give anything, it will take into new line. So once I finish j1, this one, if I finish first loop of I, it will take into new line. This will take into new line. This will take into new line, and finally new line. Let's execute, and you should get the output. Yes, you got the output. That's it. So whatever the user enters the number, the same thing you can type. So once that's a specialty of programming. Whatever the number enter, it will print the same way until it reaches the output. So I entered 1000, the same logic it follows, and it will give you the output. So here there is no space for the screen, that's why you're not seeing, but or else, so you can see it's printing perfectly whatever you are expecting. Okay, fine, that's the output. Now we have seen about for. You can take some exercise or activities for doing this, all this for loops or all this. You can do it. I can give one activity maybe. Okay, so for example, user enters, take the input from the user. For example, user enters 4. Okay, user enters 4. I need like this. Okay, I need something like this. Or else, okay, let me keep it simple. Okay, do this activity, something challenging. So if user enters 1, if it is 0, just discard. User enters 1, just type a star. If he enters 2, just type 2 stars. If he enters 3, put a triangle. This is like a straight line. This is like a point. This is a triangle. If he enters 4, just print him a square. If he enters 5, print him a pentagon. Okay, all these are regular figures. Okay, so this is a good activity. I think you can try it. Okay, it's a wonderful activity. It takes some time for you, definitely. If you enter 6, hexagon, 7, septagon, 8, octagon, nonagon, decagon. So whatever he enters, you need to print the output in that manner. Please use print and println for this, and for loop you can do this easily. It's a good challenge. Try to do it. Definitely it will take some time to analyze and think about it. Fine. Okay, now one more activity I can give. The user enters 3, next activity, next level activity. If the user enters 3, for example, user enters 3. So how many ways you can form a triangle? This is one triangle. This is other triangle. Still any other? That's it, I guess. Yeah. Just try to print these 2 triangles. Maybe you can do this way. So I shifted mirror image in this way. You can do mirror image even in this way. The horizontal I did. You can do even the vertical, and you can print. It will be same, I guess. It will be same. This here, here, here. It will be same. That's okay. Fine. This 2, and if he enters 4, I need all the possibilities. Like this is just like what I am asking you is, this is 0 degrees. If this is 0 degrees, rotate it by how many degrees? 120 here. Okay, then if he enters 4, rotate it by 90 degrees. Try to do this activity, and it should come into rhombus. Only this 2, only 120 degrees rotation here. And if he does square, it should come into a rhombus, 90 degrees. Okay, and if he enters rhombus, if he if it is from rhombus to square or whatever. Okay, so I need both the things. If he enters 3, I need this one and this one. I need this one and I need this one. But the thing is, the first one is easy to print. When you are printing second one, don't hard code and do this. Try to see how to rotate. Okay, don't use any rotate operator or rotate thing. Just try to visualize and try to rotate the situation. Here also try to rotate by 90 degrees. Don't use any inbuilt method. You only create a method called rotate, which takes the angle as 90 degrees or 120 degrees and it should rotate. Okay, that's the activity. It's a very challenging activity and it should take some time, maybe a day. Okay, these are the two activities you can try. Now the next one, let's go for next loop. I don't have time for discussing a complex questions. Maybe we'll schedule later. Okay, so let's do next loop. That is while. Let's do while loop. Now, okay, let's do some activity in the while loop. My requirement now is I want to print all the numbers, all the prime numbers. I want to print all the prime numbers less than, say, 100. I want to know what are all the prime numbers which are less than 100. So that is my activity and I am going to use while loop that we are going to do in class now. Okay, let's see how we can do. I'll ask the user to enter a number. That also I'll make him easy. Okay, need not be 100. I'll ask him to enter. Okay, fine. Now I'll be using while loop. You already know while loop. While will check the condition. So same thing. What's the difference between for and while? I'll be discussing here. So for what happens is you are initializing, you are checking the condition and you are incrementing. Everything you are doing in one line. Whereas in while, what happens is just like if it will check the condition here, initialization you need to do outside first, then it will check the condition, then increment at the end or in between you can do it. So all three things you'll do separately. So both are looking like exactly same, but there is some minute difference. Let's see what's that difference after finishing this example. So let's use while. While is a keyword. While I less than or equal to whatever the number he enters, until then I need to check. So initially I need to assign I value something. Okay, I am assigning what's the first prime number, you know already, just take it directly. 2 is a first prime number, you already know, right? 2 is an even prime, 1 is not a prime nor composite. 1 is not a prime nor composite. So it starts with 2 and 2 is specialties. It's an only even prime available for us. Fine. So while I less than number, I need to do this activity. I need to write my prime number logic code. So what's a prime number logic code? I need to write it now. So how to check, how to know whether a number is prime or not? Okay, just a minute. So I'll check if, so when a number will be a prime number, let's see. So you have numbers called 1 2 3 4 5 6 7 8 9. Let's take up to 1 to 9. Some numbers, if the condition is true for this number, then it will be true for everything. So 1 is neither prime nor composite, just leave that. So let's take a number called 4. So what I am doing is 4 is divisible by 1, 4 is divisible by 2, 4 is not divisible by 3, 4 is not divisible by 3, 4 is divisible by 4. Any number. See, obviously every number is divisible by 1, yes or no? So need not check this. Every number is divisible by itself, right? So if you take 1500, it will be divisible by 1 and it will be divisible by itself. So except 1 and itself, if any number except 1 and itself, if any number like 4, if it is divisible by any other number, then it is said to be a composite number. Which means other than 1 and 4, other than 1 and itself, if it is having any divisors, then it is not a prime number. If you take 3 for example, or else take a big number, 7 for example, 7 is divisible by 1, so don't take first and last numbers, don't take, it is divisible by itself. Does 7 have any other divisors? The 7 has any other divisors? Anything, any number it divides? 7 by 2, is it exact number? No. This one? No. This one? No. This one? No. This one? No. So other than 1 and itself, if it is having any divisors, then it's a composite number. If it is not having any divisors, then it is a prime number. Okay, that's the definition of prime number. So how to check the logic? So what I'll be doing is I'll be taking the number and I'll be dividing. So I'll start with 2, then I'll check if 2 is divisible by 1, 2, 3, all those things I'll be checking. Then I'll be writing the code. Just a moment. So 2 I'm taking. So what we'll be doing here is 2 is less than number. Okay, if okay, okay. Here only I'll terminate. So tell me how to implement this. So if I percentile, okay, is less than number, so every time I increment it by 1, I plus plus, and I'll check the logic. What's the logic? So why I'm using other loop, I'll be explaining in a minute. So what I'm doing is I'm entering a number. For example, user is entering a number as 7. So it will check from 2 to 7. So first time I want to check whether 2 is a prime or not. So I'll take all the numbers from 2 to again 2. So this 2 percentile 2, is it dividing by? It is dividing exactly. So don't take the last number. So this will not yield anything. So 2 less than 2, it will break. So next time it will be I will be 3, then 2 is less than 3, then it should be I percentile j. I'll explain you just a minute. So 3 is divisible by 3, it's not divisible, hence this is a prime number. So the prime number is 3. Then what we are doing, then 4 comes into picture. So 4, it will check with 2. 4 by 2, it's divisible, so it will not print. Then say if you have 8 is a number, so 8 by 2, 8 by 3, maintain a count. Let's see, it is not the exact code. I'll write the code, because the first time if it enters, it's not correct. Yeah, it's printing 3, 4 and 5, it's printing so many times. You don't want this here. What you need to do is you need to maintain a count equal to count plus. So you can maintain the count. So if it is exactly equal to 0, if at least one number is divisible, then it is not a prime, right? So directly you can do this. You can say not a prime, or else you can just break the loop. Else you can maintain the count. Count is equal to count plus 1. So what I'm doing is I'm taking a number. So user will enter a number, maybe 10. So it will start with a count as 1. So 10. So 2 less than this. So if any number is divisible, then you'll maintain something. So let's say flag or something. Count is 0. I'll explain you the complete code. So or else you'll store count as say 1. By default I'll make it as 0. Okay, if count is 1, we'll print the output. We'll print I, and I'll write this inside before incrementing. So what I'm doing is, so I'm taking a number, so say it as 10. So if I take a number as 10, so I'll copy this code and I'll explain. I thought of doing a simple one for doing the while loop. That's okay. Okay, let's do this code. So what I'm doing is, I'm taking initially, say that user has entered a number as, say user has entered number as 8. So now I need to check from 1, 2, 3, 4, 5, 6, 7, 8, which are the prime numbers. Okay, so 1 is already not there, so that's why I'm initializing it to 2, and I'm taking a set counter as 0. So what I'm doing next is, I'm taking in another loop. So now I should be less than 8. That's my first condition I'm checking, yes. So first the I value is 2. 2 is less than 8. That is true. Then what I'm doing is, I'm taking j as 2. So if j less than I, 2 less than 2, which is false, so it is not doing anything. So by default I should take the count as 1. So it is not doing anything, and if condition will not be checked anything, so directly the count is 1, so the output will be 2 will be printed first. Okay, next comes 3. I will become 3. So when I becomes 3, so this will be 3. 3 is less than 8, that's true. J is 2, so 2 is less than 3, that's also true. Then what happens is it will check for this condition. So the condition is this is 2, this is 3, so 3 percentile 2. 3 percentile, is it 0? So is it divisible exactly? So 3 percentile 2 is not equal to 0. It is not equal to 0. So the count will be 1. So again 3 will be printed. Then when it comes to 4, so 4 is less than or equal to 8. Again, then J will be 2. 2 is less than 4, that's true. Then what it is checking is 2 percentile J. J initial value is 4 percentile 2. So 4 percentile will check 2. Yes, it is 0 exactly. So count is 0. So you will not get any output. Then comes J will increment. Yes. So 2 less than 4 is done. So J will become 3. 3 less than 4. So 3 less than 4, which is true. Again you will get 3 as the output, which you don't want. So that's the reason what I am doing is what we need to add one more thing, because J it is checking second time. Even if it is one time, it is divisible. So even if it is one time divisible, you are breaking, so this loop gets break, so it will not check for the second one. That's good. So next one, J becomes 5, it is good. 6 it's good. 7 it's good. 8, let's check for 8. 8 less than 8, that's true. So J is 2 here first. So J is 2, and I is 8. Now 2 is less than 8, which is true. Then it will check for the condition. So what it will do, 8 by 2, 8 percentile 2, which is divisible, count is 0, so it will not print the output. And this is the logic. Let's see if it is working. Yes, 357, that's a correct answer, right? So 357 is the right answer. So if you enter some big number, still you should get the output. I'm using while and for, that's the reason it took so long time. So if you do two for loops, it will be very easy. So if I enter 100, so you'll get all the prime numbers which are less than 100. 3, 5, 7, 11, 13, 17, 19, 23, all those things. 21 is not prime, 15 is not prime, everything is correct. So in this way you'll write the prime number code, but I don't want to discuss this here. Just time came I discuss. What I want to discuss is I want to discuss the difference between while and for. So one thing you remember. So okay, here itself I can explain. While what it is doing is it is checking the limit. While what it is doing, it is checking the limit, which means, for example, user has entered 100. This is very important point, try to understand. So user has entered 100. So it is checking whether this number has reached a position of 100, a limit it is checking. When it comes to for loop, it is increment, even while loop is incrementing. What for is doing is, for is looping the value, which means I'll give one more example by which you can easily understand. Now my requirement is, I hope you everyone understood prime number program. If not, just this is a program for prime number, you can see it and you can do it. Fine. So let me do what's the difference between while and for. I want to explain. So for which I'll be doing an activity. Activity is ask a user a number and he should print the cube of, you should print the cube of the number. You need to do that activity. You need to print the cube of the number until you reach some limit, which means you enter a number, you take a number from the user. Okay, let me do that. I'll take a number from the user. I'll remove this count also, no need. So what I'll be doing is I'll call it as a limit. Now what I'll be doing is I'll take initially int I is equal to 1. Now So what I am doing is, I'll enter a number and I'll show you. I'm entering a number as 100. I'm entering a number as 100. So below 100, my requirement is below 100 I need to print all the cube results, cube of a number results. So I'm entering 1 cube is 1, 2 cube is 8, 3 cube is 27, so 4 cube is 64, 5 cube is 125. I want to restrict here. I want to restrict the result I want to restrict at 100. Result I want to restrict at 100. So what I'm doing is I am asking user to enter a number so that I'll return a result such that result set is, the cube of the number set is less than 100. Okay, then what I'm doing is I'm taking all cubes here, and if the cube is less than 100, I'm printing cube of the numbers. Here I'm using a while. So while generally when you'll use is even this is same as for loop, but in general the convention is while we will use when you want some when you already know the limit of something, then you will be using a while loop. When you will be using a for loop is meant for incrementing periodically, which means, for example, you want to print first 100 numbers, you want to just print first 100 numbers, then what you will be doing, so you will be writing for loop directly, for int. Both you can use it, even you can do it with while loop, that's okay, but the convention I'm telling 10 numbers, that's okay. So whenever you know the limit, try to use the while loop. Whenever you don't know, already know your limits, and it just for incrementing purpose every time, it's just meant for incrementing purpose every time, then try to use the for loop. Both are looking exactly the same, but there is a minute difference in terms of application purpose. In application purpose, what we'll be doing is, even you can implement this one with the help of for loop. What you need to do, just you need to type here j into j into j, and you need to write the limit here, and you need to write here j into j into j. Both are exactly same. The convention is, whenever you know some limit and you want to terminate the conditions using that limit, try to use the while loop. If the limit you are giving it statically, try to use the for loop. That's just the convention. Okay, it is not meant mandatory, so you can either swap while loop with for loop also. There is no compulsory that you need to use every time the for loop. Okay, so you can even change it. Now let's see the last one, do while loop. While loop and do while loop has a minor difference. So what's the difference? We'll see. So here I'm printing only first 10 numbers or whatever. The same while for loop condition, what we did, we can do with while also, the same thing. There is no much difference. The only convention purpose, if you know the limit already, try to use the while loop. So if I enter 10, it is printing first 10 numbers. Okay, now this is while loop. Now what I'll be doing is, I'll be doing do while loop. What is do while loop is, same thing you will do. I'm writing below this so that you will understand easily. So do this activity while the condition is met. So what I'm doing is, I am taking limit statically 100. Okay, what's the output? Let's see. So I'm taking limit as 1. Okay, so let's see what's the output from the starting. Limit is 1, it seems. I is 10, it seems. So 10 is less than 1, is it correct? 10 is less than 1, is it correct? It's false, so it will not print the output. When it comes to do while loop, what happens is, it will not check the condition first. It will evaluate the loop for the first time. it will evaluate the loop for the first time. Then from second time onwards it will check the condition. From the second time onwards it will check the condition. So for the first time it will not check the condition, it will print the output directly. You will get the output in the do while loop. So see, directly you are getting the output. So what is happening, first time it will not check the any condition. See, 10 is less than 1 is less than 10 is less than 1 is incorrect, but still do this activity system.out.println I value is 10. So first it will print the 10 and I plus plus, so I becomes 11. Then next time what happens, 11 is less than 1, is it correct? False. So next time the loop will not execute. The next time the loop will not execute. So first time it will get executed even if the condition is true or false. Irrespective of the condition, the first time the loop gets executed. From next time, from second time onwards, it will check the condition and it will do the looping. If the condition is true, then only it will do the looping, or else it will not do the looping. So first time the condition is not necessary. So this condition here is false, so will not get any output. So here the condition is in irrespective of condition, you will get one of the output as I is 10 you will get the output, and then it will check the condition. 10 is less than 1, which is false, so it will not execute from the second time. That's the difference between while and do while loop. So you will get only the answer as once. Okay, so last one. So let's see some activity. So let's see which loop you will be using for this exercise. Okay. Okay, so the question is, ask a user a number. Okay, you are asking, fine. Then what you need to do is you need to print cube of a number, and you need to print again. Next time what you need to do, you need to ask user a number, say 5, will give the answer as 125. Again you do this activity, again ask user a number 4, it should be in a loop. Okay, then you should give the output as 64. Okay, again you need to ask the number. Until when you should ask is until the user enters a negative number. If he enters a negative number, then say like bye, and you should not ask anymore. Okay, so which loop do you think is good for this? Anyone? So you are looping even your scanner. You are asking every time, yes or no? So which loop do you think is good? So you can do the same with while, you can do with for also. I prefer do while. Why I prefer do while is, I'll ask the user enter a number. See, even if it is 60, after 64 also, I'm asking user to enter a number. So this entering a number should be done irrespective of the condition. I should ask the user to enter a number. Once next time, for example, you are to enter a number, you are writing in the do loop. Okay, so user enters some negative number. Then here I'll write the number should be positive, strictly positive. I'll write if the number is now it will check the condition, -2 is greater than 0. Oh, it's false, so hence it will not ask anymore. To enter a number. I hope you are able to understand. So I'll write the do. Inside do, what I'll enter is enter a number. So then I'll write the condition. So irrespective of the condition, I'll ask the user to enter a number. So once it reaches a negative number at least once, then the user will not ask anymore. The computer will not ask anymore to enter a number. Fine. In this situation, I'll be using do while loop. So based upon your requirement, you need to use while or do while or for loop. So finally, we need to see two more statements. One is break and continue. So break means which terminates out of the loop. Let's see that. Okay, let me remove this do while loop. Let's see the last concept. So let me make it 100. so that it enters the loop. 10 is less than 100. So what I need to do is, if I is equal to 20, if I is equal to 20, what I am doing is I'm printing and I'll break out of the loop. What's the meaning of break? Let's see. So what's the first thing is, I you are taking it as 10, I you are taking it as 10, and the limit is 100. Limit is 100. So you can remove this directly. I don't want to confuse. So just write 100. So 10 is less than 100, which is true. So every time what happens is, when it is 1 it will print 1, 2 it will print 2, 3 it will print, until 19 it's okay. When it is when it is 20 only, it will print the output, or else it will not print the output. So for 1 it is satisfying the condition, no, it will not print any output. 2 it will not print, until 19 it will not print anything. If it is 20, it will print the output, yes or no. So let me make it outside so that you can easily understand the purpose. Okay, this is a good purpose, I guess. Yeah. So every time I'm printing the number, if it reaches 20, I'm breaking the loop, which means that, so 1 2 3 4 5 6 7 8 up to 19 you'll get the outputs. If it is 20, what I'm doing is I'm breaking. Break means what happens is, it breaks from the nearest to loop. What is the nearest to loop for this break? If is not a loop, if is a conditional statement checker, if is not a loop. So what is the nearest to loop for the break? This while loop. This while loop is the nearest to loop. So it will break out of this loop and the control will come here. If you have multiple for loops or while loops, then what happens is, if you write break anywhere, it will break from the nearest to loop. It will break from the nearest to loop. So what will be the output? It will print up to 19. When it reaches 20, it will break out of the while loop. Nearest loop is while loop. It will break from this and the control will come here, and you will not get any outputs after 20. Let's see that. So we'll get, it started with 10. So 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 is before this, so 20 gets printed. When it's 20, then you will not get any more outputs. After 20, you will not get any output. To be specific, let me write in the down so that it's easy to analyze for you. So you'll get from 10, 11, 12, 13, 14, 15, 16 up to 19. When it reaches 20, it is breaking, which means it will not even check for the remaining statements which are below. Break means the control will come out of this nearest to loop. Nearest loop is while, it will come and it will place its holder here. What is continue? Let's see. If I replace this exactly with continue, what happens is you'll start with 10, 11, 12, 13 up to 19, it's okay. When it is 20, what happens is, same like break, it will break out of the loop. Out of the loop it will break, but again it will continue, which means continue means it will break out of the loop and control will come here, which means it will not execute the statements which are below this if loop, below this continue, whatever the statements are there, they are not going to be executed, but from the next time onwards it will continue. Hence the name continue. Break means it will break completely out of the while loop and the control will come here, and the control will come on the 23rd line. If it is continue, what happens is, it will break out of the loop but the control will come here, which means again it will continue the while loop. So what will be the output? 10 to 19, again 20, it will not get the output because the below lines will not get executed, and then again it will continue so that you will get from 21 to 100. Let's see the output. What happened? So 10 to 19, let me rerun. It's not saved. Did we miss anything? Sometimes it will not work. The output should be from 10 to 19 and again from 21 to 100. Okay, that I'll show maybe again. It's not working, I guess, I don't know. That's okay. So you should get the output from 10 to 19 again from 21 to 100. So it continue, what it will do is it will break from the nearest loop so that it will not print the below statements, but again it will continue its executions, okay. So I don't know, it's not printing here. The output should be that. It should continue its iterations. It's not continuing. Let's see what's wrong with that. I'll see that. Okay, so any doubts in today's class, just let me know. So we'll continue tomorrow with a new concepts called reference class and reference variables. So that we'll see the next chapter. We are going to see tomorrow, reference class and reference variable. Please practice on break and continue. Okay, so we'll see and we'll continue in the tomorrow's class. Okay, then bye bye. Any doubts, please ping me. Okay, bye bye. Continue in the class.